Okay, this is an experiment on earthquakes. We are using different supports of different walls and trying to see which one can most withstand an earthquake. So here we have a mattress springboard, which we've gotten from the dump. We went to the dump and we stripped it down with a utility knife. So all that remained is this. And we attached it to a wooden board in which we put the walls on. And each of these walls has a different support, and that's what we're testing. We're going to strap 10-pound weights to the top of it so as to put a load on the wall. So each wall bears a load like a wall in a house. This first wall, this is our vertical support. This is just a regular wall. This is the cheap one, regular one. This one, we call it our O support because it only has one and it makes a couple O's, or an 8 support, whatever one. And this one is our crossbeam support. This one is used in radio towers. You've seen this in radio towers for sure, and it definitely helps side-to-side movement because of all the wood and the design it's made. And this one is our A support because the two diagonal beams make an A shape. And then the last one is called our N support because, well, it makes an N. And there's the walls. Okay, we're not quite done with the setup yet, but this is how the earthquake is supposed to go. Shake it up and down, and when there's a load on the top of it, it'll move side to side. Okay, so we're measuring the play in the walls, and that's the amount of side-to-side movement a wall has, and that should increase after the earthquake has happened. Okay, so in order to get the walls attached to the board, first you're going to want to drill a hole in the board. And then afterwards, you're going to want to put a washer, which is this round thing. They come in many different sizes. This isn't the only kind of washer you can get. You're going to put a washer on top, so when you screw the screw in, it doesn't cut the wood and screw up the initial integrity of your wall. So you're just going to want to screw this in. And once it's solid, then you're done, and just screw it on the other side, and then screw all the walls in, and you're done. Okay, so here you see the weight is tied on with 2 zip ties, well, 4 zip ties that are tied together. So you start off to tie this off with two zip ties, put them together, make sure both of the heads are facing outwards or else it won't go on right, and put it through, and make sure you actually get the wall as well as the weight, as I have not done many times. And just tighten it down. Tighten both of them so it's solid. This one's solid. And you're ready to start your experiment. Okay, so now you may be thinking, how do you measure how strong the earthquake is? Well, you don't have to. All 5 walls are on the same board at the same time. So they're all taking the same earthquake, and therefore you don't really have to measure what power the earthquake is. You can if you want to, but it doesn't matter. Okay, so we use our foot. Yes, that foot to shake the board for a minute straight. You might need a timer. So you set the stopwatch or the timer to a minute, and shake continually for a minute, and then stop at the minute end. So let's go. Go. Already you can hear the walls cracking. Okay, now we're gonna measure the play. But during the experiment, you could see how evident it was that the O support and the vertical support, how much they were moving backwards, how much they were moving side to side. It was a lot. And in the beginning, the O support and the vertical support, they both cracked. So now let's measure the play, and I'll show you how. For this part, you're gonna need a T-square, which is what we use, or something straight and tall you can use, and you're gonna need something to write this down, and you're definitely gonna need a ruler to measure how much play is in the wall. Okay, so to start off, you align, I'm just gonna say T-square because that's what we're using. You align the T-square with the wall, and then you push it forward the amount it will go by itself.
Hold the T-square is solid. Don't let the T-square move.
And do not let whatever object you're using, do not let that move, so your play does not get altered. And then you put this up. We're measuring in millimeters for our experiment, and that is 38 millimeters of play in that wall. And do that for every other wall. That was one of the weaker walls. The other walls in previous experiments, they've had little to no play. They've had 1 millimeter of play, 2 millimeters. They're very sturdy walls, and that's how you measure the play. Okay, for this experiment, there was a lot of building involved. We built 25 walls, 5 of each type of support. It was a lot of wood. It was cheap though, because we halved what a regular wall is. So we used 1 by 2 by 8 instead of 2 by 4s. So if you don't like building, then you should not be doing this experiment. But if you like building, you'll probably enjoy this experiment because it's pretty cool to see how it all comes together and works.